Hello and welcome. This is ZomCast 16 and today we will be talking about Python lists. This is one of the tutorials that I give on YouTube for Python, and it consists of different topics. We have already discussed some preliminaries, some basics like variables and types as well as strings, and today we will be talking about strings. Alright, let me see if the recording is working. So, back to our topic, lists. What are lists? You have already heard probably about arrays in some programming languages like C or C++, or some other language like C#. And in fact, lists are like arrays, which are special data structure that consist of a series of similar data types. For example, if you want to save a group of integers like a group of scores from a class in a data structure, lists in Python will be very appropriate. You can just put the numbers in and then you can do various operations on it. But note that there are different types of lists in Python, and we will be talking about more than one type. The simplest one is just like the array, which is an ordered list of variables or data, and you can iterate over them, and you can extract some data, add a new item, and so on. But there are also other types in Python, like tuples, that we will be talking about it. And also there's the type called dictionary. This is something kind of specific to Python, and it's very useful and very popular and very highly used in Python. So we will cover that as well. So let's start with simple lists. For that, let's switch to VS Code, and in that I will create a new script to show you how to create and manage lists. I create a new file. Let's save it as tutorial lists and -p.py. A simple comment in the beginning in the form of triple quote string to give an explanation about what this module does. This module is just a tutorial module for lists. So, tutorial about lists, tuples, and dictionaries. And one other type of list that I forgot to mention is sets. So we have that as well, and I will talk about it too. So to start with the simplest one, I will create, let me close this terminal, I will create a list of scores. And you see that I put it in a set like that with this operator. This is called the set operator, and you might know that it is very similar. It's exactly the same operator that we use for creating arrays in many programming languages. So let's start with numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, now we have a list of numbers, and if I want to add a new number to it, I can simply say scores.append and 11. This will add a number at the end. If I want to print the first number in the list, I say print. Again, I'm using f string to be able to use variables. First number is curly braces scores 0. This is the first number. And the next number, f, last number actually, last number scores. I don't complete it yet to mention a point here. Note that in order to access the last item from your list, you should use a negative index. Note that here we used an index from 0, and if we go up from the left, we say 0, 1, 2, 3. And if we want to access the items from the end part of the list, we should use a negative index like -1, and this will give us the last item from the list. Alright, let's actually run this and see the output. You can see that we have added a new number, 11, and the first number is 1. We printed it, and the last number is 11 because we added a number to the end of the list. Therefore, the last number will be 11. So you see that it's very easy to create a list and also to add or append new items to it. Now, what if we want to remove something from this list? In order to remove it, we say scores remove, and here we enter the index of the number that we want to remove. And let's say we want to remove the fourth number, the fifth number actually, 0, 1, 2, 3, 4. So we say 4, print removing fifth number, print after removing fifth number, and we display the list scores. You can see that we can easily print a list inside the print statement using an f string. Let's run it. Alright, removing fifth number. Is it removed? Fifth number, which was 5. 1, 2, 3, 4. Yeah, 4 is removed. So, oh, it looks like it removes the exact number that we mentioned. So what if we remove -1? What happens then? Alright, not in the list. So it's not the index, actually it's the item itself that we specify to remove. So if you want to remove 11, you simply say remove 11, or 10, you remove 10. So actually, let's do that. Removing removing 11. After removing 11, if we print it, we should see the items without 11. Yeah, 11 is removed. Very beautiful. Another interesting usage of lists that is common between different types of lists, including tuples, sets, and dictionaries somehow, is iterating or using loops over them. Let's say you have a formula that you want to run on every member of this list, and you want to see the output for each of them. Your best bet is using a loop and running a loop over these members. So in order to run the loop, we say for number in scores, do what? Running print, running in loop, running a loop, I'm using this as a log, and for number in scores, for each number, actually multiply the number by 2 and display it, or multiply the number by itself, which means give it a power of 2. So print number, there we go, and it should display the number. But instead of printing it, actually I want to put the number back in the scores. So I say I need an index for the list. So I create an index, I put it equal to 0, and here I say scores I equals number multiplied by number, and then I equals or plus equal 1, which means add 1 to I. Note that this line 23, is equal to writing I equals I plus 1, like this. But it was just a shortcut that I used. This is just a shortcut. I plus equal 1, which means add 1 to the variable on the left and put the result back in the left variable. Alright, print f string again after running loop. Let's display the numbers, scores. Let's run it, but let's clear the console and run it. There we go. You can see that every item has been multiplied by itself, or it has gone to the power of 2. Very beautiful data structure and very useful. Before we switch to the next type of lists that are somehow similar and somehow we can use the same techniques that we used for working with lists, with simple lists on them, let's mention something else about lists. Note that in lists you don't have to use only one type of data. You can use heterogeneous data types, like I can have a string among these integers, or I can have a float among these integers. So I add some other non-homogeneous data types to my list and then display it. Print adding non-homogeneous or heterogeneous list members. I say scores, append, I add a float, for example, like 20.5, and also scores one string like Jack, and what else we can add? There are different data types that you can add, but for simplicity it's just sufficient for us. Two different data types that is different from the initial data type that we used. Now print it after adding heterogeneous or after adding 20.5 and Jack. Print again f string. Note that sometimes I'm using single quotes for strings, sometimes double quotes. It's just a preference of yours. You don't have any obligation to use each of them. You can use the one that you like. Let's print it. Actually, I could have printed in the same statement, but I do it in this print. Scores, run it. There we go. You can see that our list now has data types that are mostly integers, but also some members that are float or string. It's very nice. So I hope that gives you a glimpse of how lists work in Python. Next, we will be talking about tuples. Actually, let me talk about sets first, sets and dictionaries, and lastly, I will talk about tuples. Starting lists. Print, creating set, creating a set. I name it my set. And what's the difference between lists and sets? You will know now. First, the operator that we use to create it is different. It is curly braces instead of these angle brackets. So first difference is in the curly braces that we are using. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, or let's make these a little bit different. Like start from 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. This is a set, and if we want to print it, we simply say print list, make it f string to use my set in the string. You can see that it is printed. There we go. Now if you want to add something to it, we just say print adding some new member like 31, adding 31, and my set. Note that we don't have append here because in lists order was important, but in, let's say, this new type of list that is called set, order is not important. You just say add and Python decides where to add it. So we say add 31, and if we look up the documentation, add an element to a set, This has no effect if the element is already present. There we go. If we print it now, print f string my set members, my set, run it. There we go. 31 has been added, as you can see. So the main purpose of sets is to check membership. Like you have a set of people and you want to see if some incoming person or some incoming ID is in the list already. So Python has a very good and suitable data structure for doing that, for checking that, using just this, using set. Let's show this with an example. For example, I want to check the membership of 27 in the list, in the set. I say print checking membership of 27 in the set. I say print f 27 is in the set, true or false. Here I do a simple check. My set is get is subject oh no, actually it's very simple to check. You only say 27 in my set. There we go, and this will give us true or false. Let's run it. There we go, 27 is in the set. Now another check. Let's copy these lines for another number. This time I'm checking the membership of 50 in the set. 50 is 50 in the set. If we run it, false. Come on. 50 is in the set, false. 50 is not in the set, as we know. And also for adding members to the set, we do use these simple methods. Print f adding new member 31 to the set. Let's add some other number like 40 to the set. And once we added, it should be in the set. I said my set add. Oh, actually I already showed how to do it. Oh, sometimes I mess up. To remove it, print removing 31 from the set. From set, print. Actually, let's remove first my set. Remove and 31. Print f string after removing 31 my set. Let's print it. There we go. 31 is not there anymore. There's another method that is useful, you might find useful when working with sets, and it's pop. My set pop, or my set pop. And what it does, as you can see in the documentation hint, remove and return an arbitrary set element. This just removes some arbitrary member from this set, and we don't know which one. Python decides to take one of them out and give us. So in order to take out all the members, again I create a loop, and meanwhile this shows you how to work with loops and sets and running loops on the sets. I say for item in my set, which means go iterate over the set, over every single item in the set, and then print one of the members, and we don't know which member. Python decides that. But also print some log to give a hint what we are doing. Running loop on the set and removing items in the loop. All right. Ellipsis. Let's run it. Actually, after removing every single item in the list, in the set, from the set should be empty. So if we print it, it should be empty. Print f-string set after removing items. My set, it should be empty. Let's run it. Set changed during iteration. What? Oh my. Oh, we did a stupid thing. I did a stupid thing because we are running a loop on the set, and at the same time inside the loop we are modifying the members, and this breaks the loop. It just confuses Python. We shouldn't do it. So instead of popping items, we can just get one of the items. Yeah, get my set, my set yeah, let's forget about pop and loop for now, because for looping you saw that a list is a better option. So here we just remove two items by popping my set pop, my set pop, not loop, removing items, two items actually, and then display it. There we go. You can see that 21 has been removed from the set, and also 20, 21, 22. Both numbers have been removed from the beginning of the set. All right. For now, it's okay for the lists and sets. It's okay. We have nothing to do anymore about these two items, about these two structures. Next, we have tuples to discuss and also dictionaries. In order to not confuse you, I'm considering to put it for another session actually.